Yes, hey, welcome back. Today, let's solve the problem. Find pair given difference. So, what the problem tells is that you will be given an array of size n and integer x, and you have to simply return one if there exists a pair of elements in the array whose absolute difference is equal to x, or else you have to return minus one. So, what does that mean? So, if you consider this array and the target is 78, so what you have to do? You have to take this value. In other words, you have to take 80 and 2, and you have to take the difference of them. And if the absolute difference is equal to 78, you will return 1. So that is the thing. So if you have solved lead code, and if you remember the first problem, it's called two sum, where you find two elements which add up to the given value. And over here, what you have to do is you have to find two elements which subtract to get the given value, the given target value. So what we can do is first we can do a brute force search where we use two loops, go through all the elements present, and if any two elements, what you call the difference of any two elements becomes equal to the target, then we can return one or we can return manual. So first, let's try to write out the brute force solution. So I don't even think I have to tell what has to be done. So just go through all the elements in ARR1 in the array, and for j I plus 1 to length of the array. So if abs of I minus ARR at the position j, if it by chance becomes equal to x, that means we have found the target, we will return 1, or if what we will do minus 1. Yeah, this is a purely brute force approach, and it will work, but when you submit it, so what will happen is that you will obviously get TLE, mainly because, okay, so this is a very big test case. Yes, that is what is expected. So what can be done? And so the first thing is to do is to actually go through the entire problem. And yeah, we went through this part, but we did not look at the entire problem. If you go down, they're telling that the expected time complexity is of n log n. So what does n log n mean? That means sorting is involved somehow. So what can be done? So yeah, since n log n is there, what we can do, we can actually solve. So okay, yes, we sorted, but now what can be done? So what will be the output of the first array if we do this? 2, 3, 5, 5, 20, and 80. So what can be done is we can have two pointers. This is kind of sliding window approach. It is a sliding window approach. We'll have two pointers, L and I and J. When I will be pointing to 2, J will be pointing to 3. And if by chance I minus j, you can do j minus I directly because it is guaranteed that the jth element will always be greater than the ith element. So if by chance error at the position j minus error at the position I becomes equal to the target, then we can actually directly return it. So when you consider 2 and 3, the difference of 2 and 3 is actually 1 and your target is 78. So what you do, since the target value is greater than your current target, like current value, so just increase the value of r or j over here. It will become 2 comma 5, and again this is obviously not equal to your target, and it is very smaller than target. So again increase 5 comma 2, again 2 comma 20, again it's 18, which is not equal to 78. But when you do 80 comma 2, what will happen is that you will get the target 78 and you will return it. So let's just do a driver for the second test case also. So we have 20, 50, 70, 80, and 90. So let's do a dry run for this. The target is what do you call 45. So we'll never get 45. So but just let's do that. So 20 minus 50 is less than 45. So include this. 70 minus 50 is greater than 45. So increase I. So 50 minus 70 is less than 75. So increase R. 50 minus 80 is less than 75, 45. So increase R. 90 minus 50 is also greater is less than what you call 45. So increase R. And as you see, R went out of bounds. That means that you could never reach your target. So you will return minus 1. And you might have thought, okay, so what about if we did the same thing like we did the sorting part, but we had L over here and R over here, and then like we added, so like what you call, we subtracted both the values and checked if it is equal to target, we will return 1. And if it is greater, then we will subtract R. And if it is lesser, then we will, what do you call, increment L. And even I thought this approach would work, but there are some test cases where the approach won't work. And yeah, let's take one test case for example. So if you have if you have 1, 2, 7, and 10, and your target is 8, so what you'll do, you'll have R over here, L over here, and R over here. And when you do R minus L, you will have 9. So 9 is greater than 8. So what you will do, you will subtract R, and R will come here. So, but 7 minus 1 is less than 8. So what you will do, you will increment L, and 7 minus 2 is also less than it. So again, you will increment L, and you'll see L is greater than R, and you will tell that, okay, there is no pair which adds up to 8, like we subtract to 8, and you'll return. But obviously, 2 and 10, when you take the absolute difference, you'll get it. So that is the reason why L, R approach won't work, like having two pointers at the end. This is a sliding window problem. Sliding window two pointer problem, not L, R two pointer problem. So let's do that. We will have I, comma j equal to 0, comma 1, and while I is less than length of ARR and j is also less than length of ARR. So what you can do, you will do I plus is equal to 1 or j plus is equal to 1, and at the end you will return minus 1 if the pair was not found. So now let's go through the core logic of actually adding the pairs, like summing or calculate the absolute difference. And again, there is no need to calculate absolute difference, mainly because we have assured that j will always, AR at the position j will always be greater than ARR at the position I. So uh, we will call it this is equal to ARR at the position j minus ARR at the position I. And if by chance, if the diff is equal to the target x, then you will directly return the value 1. And if the diff is greater than x, so what you will do, L plus is equal to 1, or else R plus is equal to 1. Okay, it's not L and R, it's I and J. So let's just go through it. If it is equal to x, we'll return 1. The difference is greater than x, so we have to shorten our window. So we are doing I plus is equal to 1, or else we have to, what do you tell, increment our window. So we are doing j plus is equal to 1. So let's just compile and run. Okay, we are not taking care of one case. Like, see, I should never be equal to j over here. And when you do this, there is a chance that I might become equal to j. So what we'll do, I is not equal to j, and then we'll add the remaining conditions. So again, we'll do compile and run. Let's just submit and check it out once. And okay, the on the test case was passed, and that is what is expected. And since this is very similar to sum, we can actually follow a very similar approach over here. So what we can do is we can have a seen dictionary or visited set or a dictionary, whatever you want. And so what we can do is, as soon as we encounter any value, we will just check if that value added by the value of target or the value subtracted by the value of target, if it exists in our visited, and if it exists, that means that we have actually found a pair. And if it does not exist, then it means that like the value is not there, so we'll just add it to our set. So what does that mean? First, let me write it out. So I in the value of ARR, if I plus x or I minus x, so this x plus I, or what am I doing? Uh, the absolute value of x minus I, if it exists in our visitor, it's made of absolute over here. So then what we'll do, we'll directly return the value 1, or else we'll add it to our visitor, and then directly we'll return minus 1. And be careful, you should not add x over here, you should add I. It is just do a compile and run. Okay, it should return minus 1 over here, not 0. Okay, and let's just submit it once and check if it works. Then I messed up the ordering over here, it should be I plus x or I minus x. Let's just copy this test case and custom input. Okay. If I'm doing the wrong comparison, uh, this should also exist in visitor, or I minus x exists in visitor. I forgot that again in visitor over here. And now we have to interchange the place over here. I plus x won't matter, but I minus x will matter. Let's just do compile and run. And now let's submit. And yeah, this approach also works. So how does it work? So let's just take first element, first array the example. So we have 5, 20, 3, 2, 5, and 80, and your target is 78. So first you go and check 5. And yeah, since there is the absence of 5 plus 78 or 5 minus 78 in the visitor dictionary. So visitor test, so what we'll do is we'll add 5 and then we will check 20. So again, there is absence of 20 minus 78 or 20 plus 78 in the dictionary, so we'll add 20. And then we will go for 3. And again, 78 minus 3 or 78 plus 3 minus 78 or 3 plus 78 is not present in the dictionary. So we'll go forward and we will reach 2. And what we'll do, we'll again check 2 plus 78 or 2 minus 78 is not present. So in our currently it's not present in the dictionary. So we'll add 2 also and then we'll reach 5. And when you do 2, 5 plus 78, it's not there. 5 minus 78 also it's not there. But when you go to 80, you'll see that 80 minus 78, which is actually equal to 2, has been added in the dictionary. That means that the or difference per every. So you'll add it, you'll return 1 or you should return minus 1. Yeah, that's how the approach works. And yeah, that's all for it. And thank you for watching. Goodbye.